So today we're going to begin chapter 8. We're going to cover section 1. Today we're going to talk about similar polygons. Now when you're doing the homework for this section, every question, there's 15 questions. Every question needs work except for number 1 and 2, because it's just like vocab, and then number 12. The rest of them, you're going to be setting up proportions, and I want to see the proportions you're setting up to solve for maybe a missing side length or an altitude or things like that. So let's go ahead and take a look at what similar polygons are. So similar polygons are just two polygons that have the same shape, but they're going to have different sizes. So one will be small, one will be large. All of the corresponding angles in similar polygons are going to be congruent. So the angles will be congruent. However, the sides are going to be proportional. And that's mostly what we're going to be doing in the homework, is to find the missing sides of our polygons. And a lot of times they're going to be triangles. So the symbol for similar is this wave-looking thing that's in between the ABCD here and the MNOP. This is the symbol for similar. Now, on all of these corresponding angle matches here, this should be a congruency mark because all angles are going to be congruent if the triangles or the polygons are similar. So you could change those equal signs to a similar. All corresponding angles in similar polygons are going to be congruent. However, their sides are going to be proportional. Now, whenever you're given a similarity statement, just like before when we saw congruent figures, the order of the letters is important. So for example, the first letter that's listed here, A, is going to be congruent to the first letter here, M. And that's this first statement here. And then the next letter, the B, the second letter, will be congruent to the M. And then the third letter, the C with the O. And then lastly, the D and the P. So those will be your congruent corresponding angles in the similar polygon. And then we can do the same thing for the side lengths. However, when we saw the congruent figures, we would have said that AB was congruent to MN. Now, what we're going to see is AB is going to be proportional to MN. And we're going to put it in a ratio or in a fraction. So notice the first two letters that are listed here, the A and the B, are going to be set into the same ratio with the MN. Now, on the quiz, I'm going to ask you to list the corresponding angles. I'm also going to ask you to list the sides in a statement of proportionality. So when you see this request to list the sides in a statement of proportionality, this is what I'm looking for, is you to find the corresponding side matches, and then you're going to write them as ratios. When you're asked to check to see if two polygons are similar, each one of these ratios will need to be the same. They will need to simplify to the same ratio. So let's say, like in this particular picture, they're changing figure A, B, C, D into MNOP, and notice it's a scaled down version. So that's what's going to happen. It's either going to be a reduction and it'll get smaller, or the figure might get larger and it'll be an enlargement. And what we're going to see is we're going to be able to find that scale factor, or what they multiplied each one of the side lengths by, to get the corresponding new polygon. So let me add some numbers to this to show you how the ratios would all simplify to the same fraction or the same ratio. So let's say that AB is 6, DC is 10, and that AD is 8, and BC is 8. And then let me add some numbers to the smaller one. So now, if I take all the corresponding sides, so for example, AB here is with the MN, which was here. So if I do AB over MN, 6 over 3 simplifies 2 to 1. And then if I go the next one, the BC with the NO, that corresponding match needs to also, it shouldn't be 6 over 3, sorry, it's 8 over 4. It also needs to simplify to the same ratio. And then if I do the next one, the CD with the OP, 10 over 5, also simplifies 2 to 1. And then lastly, if I take the AD and put it over the MP, 8 to 4, 2 to 1. Now, if at any point these did not simplify to 2 to 1, then these figures would not be similar. All 4 sides of these particular quadrilateral, they would all need to simplify to the same ratio. Now, when it asks for a scale factor, what we're going to do is we're going to put the new figure's number over the old. So this one actually, we would have to flip it, and the scale factor here would be 1 to 2. Because what they did was they multiplied the larger figure side by 1/2 to get to the new figure. Now, it's always multiply, because technically it looks like divide by 2, but really what we're doing is multiplying by 1/2. Okay, so when you're told that two figures, whether they're polygons, triangles, whatever it is, if you're told that they're similar, then the ratio of the corresponding sides of the two similar polygons will give us the scale factor. So in other words, the scale factor is just the ratio of the corresponding sides. And really what it is what did they multiply the original figure by to get to the new figure? That's the scale factor. So for example, on this, these are both equilateral triangles and equiangular. So it really doesn't matter what side matches, because if you notice in the small triangle, the ABC, all 3 sides are 3s. And then in the larger one, the EFD, they're all 6s. So in order to find the scale factor, what we need to do is take the new figure, which is usually the one on the right. So we're going to take the right triangle's numbers and put it on top of the left triangle's number, and then simplify. So 6 over 3 simplifies 2 to 1. So my scale factor is equal to 2. Because what I did was I took all of the numbers here in ABC and I multiplied them all by 2 to get the new larger figure. So that's what you're looking for when you're asked to find a scale factor. What did we multiply by to make the new figure? Now, sometimes it's not always this easy where it's a whole number. It could be a fraction. And that's where you're just going to take the two side lengths, the two corresponding side lengths, put them into a ratio, and simplify. This should be 2 over 1. Thank you. That should be 2 over 1, which simplifies to 2. Sorry. Good catch. Okay, so for the next one, it's got 4 different things we're looking to find. First, they want us to find the scale factor of what did they multiply quadrilateral ABCD by to make it into quadrilateral MNOP. So what I'm going to do is I'm going to start matching and writing out my statement of proportionality in order to find my scale factor. So If it asks for a statement of proportionality, we're going to take it letter by letter. So again, you would have been told that A, B, C, D is similar to M, N, O, P. So then we can go through and match. So if I take the AB and I put it with MN, and again, I'm going to write my statement of proportionality and I'm going to put it right over left. So I'm going to put the MN over the AB. And MN's value is Y and AB is 12. Now that's not giving me a scale factor. I've got a variable there. So let me go to the next two. So then if I try the BC and the NO, BC is 4, NO is X. That's not helping me so far. And then if I put BC here, that's got a 4. Now, the letters themselves, this is forming my statement of proportionality. So now let's go to the next two, the CD and the OP. CD, OP. So OP, CD. OP is Z. CD is 14. I still don't have both sides with a number yet. So I still haven't found my scale factor yet. So now let's try the last one. And I got the MP, which is the first and the last, matching with the AD. So MP to AD, this is going to give me my scale factor. I don't have a variable now. So my scale factor is a simplified ratio, so 8 over 10, which reduces to 4/5. So this is my scale factor. This is also called the corresponding side length ratio. Now, when you're doing the homework tonight, number 2, it's going to have the variable K, and K is the scale factor. So when you get to number 2, it's going to have K equals, and what they want for K is the scale factor. And again, it's what did they multiply the original figure by to get the new one. So generally when it's set up like this, it'll be a picture on the left and a picture on the right, but you're going to put the right pictures, numbers in the numerator, and the left pictures, numbers in the denominator. Okay, so we found the scale factor, which is the answer to part A. Now what we're going to do is we're going to use that scale factor, and we're going to set up 3 different proportions to find the values of X, Y, and Z. So for part B, I need to find the value of X, Y, and Z. I'm going to use the scale factor. And I'm going to set up 3 different proportions. So the first one, I could do X if I do it alphabetically. I'm using this ratio, X over 4, and I'm setting that equal to the scale factor. And now I'm going to cross multiply and divide. So I'm going to multiply diagonally, X times 5 and 4 times 4. So this will give me 5X is equal to 4 times 4. 4 times 4 is 16. Divide by 5. And X is equal to 16 over 5. Because this is a side of my polygon, I want you to convert it to either a mixed number or a decimal. So if I make it a mixed number, 5 will go into 16 3 times with 1 left over, or 3.2. So you're using your calculator, so you can divide it. However, if you end up with a repeating decimal, then I'm going to want it listed as a mixed number. So that is the value of X. Now we need to find the value of y. So the ratio I got that had a y in it was the y over 12. It was the mn over ab. So y over 12 is equal to the scale factor. Again, do the cross products. 5 times y, 12 times 4. 5y is equal to 48. I need to divide both sides by 5. 5 will go into 48 9 times with 3 left over. I can make it a decimal, and it's 9.6. Now these are all units. If this would have been labeled with inches or centimeters, then I would put that unit, but it didn't have any kind of measurement in the picture, so I'm just going to label it as units. I still need to find z. Z was the purple. It was the OP over CD. So z over 14. Set that equal to the scale factor and cross multiply and divide. So 5z is equal to 4 times 14. 4 times 14 is 56. Divide. 5 goes into 56 11 times with 1 left over. So I would either accept 11 1/5, 11.2, or the improper, but again, when it's a side length, I'd prefer a mixed number or a decimal. So this is all the answer to part B. So when you're doing the homework tonight, a lot of it is going to be solving these proportions. So I want to see how you're setting up the proportions, how you're cross multiplying, and then dividing. For part C, it wants us to find the perimeter of each one of these quadrilaterals. And remember, for perimeter, we need to add up all the sides. So for the perimeter of figure ABCD, I already had all the numbers for that one. So all I had to do was add 10 plus 12 plus 4 plus 14, and the perimeter would have been 40 units. That was for the first figure. Now the smaller figure, the MNOP, I could either choose to use the fractions or use the decimals. So if I did it as using the fraction answers, it's not bad because they already all had a common denominator. So then that would have given me 31 and 5 over 5, which equals 32 units. Now, I could have also added them as the decimals. It doesn't matter. So 8 plus 3.2, 9.6, 11.2, and I still get the same answer. So just remember, for perimeter, we add up all the sides. And then the last one wants me to find the ratio of the perimeters. So for part D, all I do is take the ratio of the figure on the right, 32, and put it over 40, and then reduce that ratio. I can divide them both by 8, and I get 4/5. Notice the ratio of the perimeters is the same as the ratio of the scale factor. This will be an important fact to remember. So to summarize this, and we're going to see it coming up on another slide, the scale factor is the same as the ratio of the side lengths, and it's the same thing as the ratio of the perimeters. They're all going to be the same number. So all three of these would give us the same ratio. And in this particular problem, it was 4/5, 4/5, 4/5. And notice they're all the same. So just understand the terminology. Again, what I highlighted here in purple is called the statement of proportionality. Understand this term because you're going to have to do this on the quiz. Now, if it also asks you to list all the corresponding congruent angles, that's when you just go back to that statement. First letter A was congruent to M. B, congruent to N. C, congruent to O. And D, congruent to P. So if I ask you to list the corresponding congruent angles, that's what you would list. If I ask you to list the side lengths as a statement of proportionality, that's what I'm looking for, is you to match the corresponding sides in ratios. So this would be just the corresponding congruent angles. Okay, so what I wrote on the previous slide, here it is in words. So corresponding lengths in similar polygons. So if you're told that two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor. And what we just saw with the perimeters, it's also equal to the ratio of the perimeters. So all three of these ratios will be the same. The scale factor, the ratio of the perimeters, and the ratio of any of two corresponding lengths in the polygon. And you would use that similarity statement to find the corresponding sides. So in the diagram, they're telling us that triangle TPR, this one over here, is similar to this one, XPZ, on the right. They want me to find the length of the altitude. Now, if you remember, before Christmas break, we learned about different parts of the triangle. We learned about medians and altitudes and perpendicular bisectors. So yes, that was in the first semester, but you still need to know what an altitude is moving forward in this second semester. So in the particular picture here, PS is an altitude and so is PY. Remember, the altitude is always the perpendicular segment coming out of the vertice. And there's actually three altitudes in this, but we're only referring to PS and PY. So here what we need to do is we need to find the scale factor or find a ratio of some corresponding sides. Now the only sides that have numbers in the blue one is this side TR here. And TR, it's the first and the last letter. And you're going to see that it's going to correspond to the XZ in the red triangle. So to find the length of XZ, I'm going to add 8 plus 8, and the length of XZ is 16. For TR, it's going to be 6 plus 6, and TR has a length of 12. So what I'm going to do to find my ratio of my corresponding side lengths, which is also the scale factor, I need to do the new figure, or the right figure over the left. So I'm going to take the 16 and put it over the 12. And my scale factor is going to simplify 4 to 3. This is going to be the scale factor that I'm going to use in my proportion to find the length of PS. Now I'm going to just say that PS here, I'm going to say that this is X. just to make my proportion a little bit easier. So what I'm going to be doing is this right here was xz over TR, and I'm going to set that equal to the altitude in the red one, which is PY, over PS. So let me fill in my numbers. So I already simplified the XZ over TR. That was my 4 to 3. The length of PY is 20, and I don't know PS. That's what I'm solving for. So now I'm going to cross multiply. I get 4 times X, 3 times 20, divide by 4, and X equals 15. And I had stated that X was going to be the length of PS. So PS is equal to 15. Okay, so what we already talked about, that the ratio of the perimeters is equal to the ratio of the corresponding side lengths, which again is the same as the scale factor. So we've already technically saw this happen, but now it's officially presented as a theorem. Again, don't memorize the number. This is just telling us that this is the first theorem that we're learning in chapter 8. That's why it's called 8.1. And it's called perimeters of similar polygons. And when we did that first example, remember we had the perimeter of 32 over 40, which simplified to 4 to 5, which was also the same as the scale factor. Let's see another theorem, and then we'll do one more example. So again, don't memorize the number. This is called the areas of similar polygons. So if two polygons are similar, then the ratio of their areas is going to be equal to the squares of their corresponding side lengths. So for example, you're going to take either the corresponding or the ratio of the corresponding side lengths and square it, and that will give you the ratio of the areas. Remember, this is also the scale factor. So you'll also, the other way to think of it as is the scale factor squared equals the ratio of the areas. So let's try an example of it. They're showing you here, it doesn't matter which side lengths, which corresponding side lengths you choose, they all should be the same. And then once you find that ratio, you have to square it. And we're going to use this to find a missing area. And that's what we're going to do in the next example. Okay, so in the diagram, they're telling us that that smaller quadrilateral, the GHJK, is similar to the larger quadrilateral, LMNP, and they gave us two of the corresponding sides. So they gave us a side from the smaller one, the KJ, or the JK, which is the last one, last two letters, and it's going to be corresponding to the NP, this one here. So these are my corresponding side lengths. So what I can do here is put them into a ratio. So I could do PN over JK, or KJ, it doesn't really matter. So 21 over 7 is my corresponding side length ratio. And I'm going to reduce this. This will simplify 3 to 1. Now, notice what they gave me is the area of this smaller quadrilateral. They want me to find the area of the larger quadrilateral. So what I'm going to do is set up a proportion, but remember, I need to take this side length ratio, which is also my scale factor, and I need to square it. So the proportion I'm going to set up is going to be Pn over Jk squared is going to equal the area of GHJK over the area of LM and P. So let me fill it in because I have this number and I'm going to put it here. This is going to be my variable. So let's take our simplified scale factor, our simplified side length ratio, put it in. They gave me the GHJK is 84, but I don't know the area of LM and P. So now I'm going to square the purple. 9 over 1 equals the 84. Oops, I did that backwards. The X needs to go on top because I'm doing right over left. And now I'm going to cross multiply. And X equals 756 meters squared. And remember, X was going to be the area of LMNP. The biggest mistake is everybody forgets to square that corresponding side length ratio. You need to square it and then solve the proportion. Now, if you didn't want to simplify the fraction and you wanted to work with it as the 21 over 7, you could still do that. However, your number is going to get really large. This will give you 441 over 49. And then cross multiply. And then you get 37,044. And then have to divide. But again, you're using calculators, so it wouldn't be that bad. But in the past, we did not use calculators for this chapter. So it was kind of intense on the calculations.